Welcome to Spring LIB.
7.65. So we have an accident scene. We have a road that's level. We have a skid mark from a car from when it slammed on its brakes and started sliding because the brakes locked. That's 98 meters long. The coefficient of friction was 0.38. It was a rainy day or something, and this is what they've estimated it to be. And so we want to figure out what the initial speed of the car was. And then it also asks us, why does the car's mass not matter? Because we're clearly not given that, but we're expected to find what its initial speed was. So we need to figure out, or somewhere in the solving of this problem, we'll see why the mass is irrelevant. So here we have our very boxy car. We have its weight directed downward and the normal force directed upward. And then we have the force of friction directed opposite the speed of the car, or opposite the velocity rather. So the force of friction is the coefficient of friction times the normal force. This is a level road, so the normal force is equal to the car's weight. So the work that is going to be done by our friction force is equal to the change in kinetic energy. So our friction force times the distance that the car has slid times the cosine of 180 degrees, because the force is directed opposite the displacement, is equal to the final kinetic energy, 0, minus the initial kinetic energy, 1/2 mv initial squared. So we have negative mu m g d equals negative 1/2 mv initial squared. So we can see here, this is why the mass doesn't matter, because it cancels out on both sides. The negative ones also go away. And so the initial speed of this car was the square root of 2 times the coefficient of friction times g times d, which works out to be 27 meters per second.